What's up, guys? My name is Alberto Munar, and today I'm going to demonstrate the SRT521 Lab 9. It's a linear regression. So from the previous lab, we are classifying the data, right? The data points. But here we are. Linear regression is about we are predicting what's going to happen based on the data that we have right now. So in this lab, we will focus on simple and multiple linear regression. Regression can be used for classification and for prediction. In this lab, we will use regression to predict the size of data reads, a number of record compromise. Okay, so first up, we will have to understand the data, read the given data manually. We'll have to go deep dive into it and look at the data itself, right? So for task 1, for this arrest persecution, I manually transform the string into numeric. So no unknown and one, but you can see my program transform into the program will do the transformation itself from a string to numeric, right? So for now, I will show you the manual way how to do it, and I also clean some noise in the total effective column because I can see noises there. So I selected this features column, right? Total affected and the arrest persecution. And so the name of my program in this task 1 is task1lab9.py. So let's see that in action, guys. So this is my modified program because this program is originally from our professor, Asma Paracha. Just modified so that it will work on lab 9, task 1 by me. And yeah, this is just our x and y variables, right? Empty variables. And so we will have to print we will have to input 2 files here, right? I made these 2 files here are the input for my program. And mind you, I already prepared that already, right? So these 2 files here, right, were the files that I use. So this one, I removed it says without the AP, arrest persecution, because this is the full data set, the X input, like the dependent input, and this is the independent input. So you can see that over here, guys, right? So yeah, from here, right? I explained it there. And so we have the linear regression as our model, right? And we just have to print the coefficient of determination and other values, right? So yeah, the coefficient of determination and the intercept and the slope, right? That was mentioned. And this is a test model we will do for prediction and compare with the actual response, right? Okay, and we will have to compare the actual response. Okay. And we will have to apply the model to the new data, right? This is what it says here, and the new data and testing new predict values. And over here, guys, this is just to show the scattered data printout or plotted out, so that you can have idea how's the data set scattered in the graph. Okay, guys, so let's see this in action, right? So let me run the program in the CLI. All right, so we have this. All right, so yeah, this is just the scattered plot, right? Remember our legend. All right, 0 for no and 1 for unknown, and 2 for yes over here. So there's only few yes. So I transform the data that way for the arrest persecution, and so it shows group over here from the scattered graph plot, right? Right, and so yeah, we just have to discuss the output. Okay. Okay, so very important here, guys, for the output is the coefficient of determination. It produces 0.8616, right? And the output shows the coefficient of determination r squared, right? Indicating a reasonable fit. Pretty much 6.86 is reasonable fit. Okay, and the program demonstrates training of linear regression model and testing it both existing new data and visualizing relationship between the 2 columns in the data using scatter point, which is I did it last over here. All right. Let's move on to task 2. Okay, for task 2, we would have to do simple linear regression by picking 1 column, which I think will be most important in predicting size of data breach. Create a linear regression model, analyze the result, and calculate the accuracy of my model by printing coefficient of determination, root mean square, error, intercept, and slope. Okay, we haven't discussed root mean of square of error, but if there's a line, right, and your prediction is the difference, like if this is a line, this is supposed to be the line, and then the prediction distance is the error that the machine had made in predicting. So that's the root mean square error, right? And the intercept, we discussed that in the slope. Number 4 is predict the values using your model both for your training and your test data set, and compare the actual values with predicted ones and plot the 2 values together in a line plot, and describe your finding as how the model works with the new data, and compare the accuracy of your model based on the different columns. So the name of my screenshot here is task 2 lab9.py. So let's see this in action, the task 2. Okay, so So let me execute this, guys. Okay, let me just put this on first. All right, let me just execute it. Same thing. Task 2, lab 9, lab 2, right? So over here, we can see it executed. We can see the mapping of our fields, right? Fields record, right? And in this case, this is how the machine does itself. It didn't change the data set. It just do it in a memory. This is how it looked. All right. Yeah, the machine does itself over here by transforming this column to a numeric value, and those are the numeric values that we can see here, content, right? So the machine or the program does automatically change the column into its memory. So like I said, it picked up that one column, bridge type, and it transformed it, right? As you can see over here. And then I create a regression model, right, over here. And then analyze the result and calculate accuracy by printing the coefficient of determination, right? So it took those things and it put in the model and make prediction on the training and testing sets. And then it print this one, the coefficient of determination and the root mean squared error as requested by the lab, intercept and the slope of coefficient, right? And plot the actual values and the predicted values and compare the actual values with the predicted ones. So let's see with the plot over here, right? So as you can see, bridge type, total affected, right? And yeah, the linear is pretty much, the line is pretty much acceptable, right? Oh yeah, it's not there, it's supposed to be here. This one is kind of big, but we can adjust that on the next task. Close that one there. Moving on to task 3, multiple linear regression. Pick 2 columns this time. Remember last one we picked up 1 column, and this time it's 2 columns. And it's important predicting the size of the data. Create the linear regression model, analyze result, and calculate the accuracy of my model, and calculate coefficient of determination, root mean, error, and intercept, and the slope, and predict values using model, training, and test data set. Compare the actual values with the predicted ones, and so on. So the name of my program here is task 3 lab9.py. So let's see this thing in action. All right. So we have this, and I'm just gonna run this, guys, while waiting. And so yeah, that's the CSV input, and this time the program does it in the memory without us knowing which one is bridge type, right, and the other one is inside out, pretty much actually, right? Those are the columns that I pick, and it will transform itself in the memory and does it in the program without changing the input independent input file, right? So pretty much the same thing. Our Y is the arrest prosecution, and this is our X input, right? And then we split it, and then this is our model, right? And it fit it in the model. And this time we just have to do the prediction and model evaluation by printing these this requirement, R squared, RMSE, and intercept and slope, just like the previous one, and then the plot over here. Okay, so let's see the plot over here, right? So arrest prosecution, as you can see, the R4, 0 is no, 1 is unknown, and 2 is yes. So those are scattered group, right? The RMSE is actually very low, which is acceptable because the error is 0.58. It's still big, but pretty much the program does itself, and the level of error is not big, so that's pretty much acceptable. Okay, moving on to task 4, overfitting versus underfitting. So we have to change the training dataset percent and evaluate the model to obtain in its case using coefficient of determination and RMSE, the error made by the program. Which attribute is better to measure, the accuracy, coefficient of determination, or the RMSE? Okay, so the name of my program is lab task 4 lab 9. So let's get to see that in action. Thank you. So over here, guys, so I just ran it, right? And as you can see over here, so yeah, this is the library that we imported, linear regression, matplotlib for the plotting, sklearn, and the pandas. And yeah, I use the same program in lab 9 over here. The only thing that get added is what's the lab requirements is to change the size of the training data sets, right, to 70%. And we use the same model, linear regression, and it took all that, and the result has improved. It becomes 0.59. That's okay. It got lower. The error got lower from this program here. All right. So let's see the graphs, and the graph shows like this from the label auto prosecution, arrest prosecution, right? I made that a label, and these are the scatter plot. It says that actual is this, and these are the predicted results. And same thing over here, right? The red one are the predicted. So it's pretty close prediction, and error 2. So that's it for lab 9, and thank you for watching, and see you in the next lab.